Now, is that on? Yeah. Here we go. Okay, look. So last time we were looking at gravitational fields, okay, and we had things like gravitational field strength. You remember this? Now we're going to continue with fields, but onto a different type of field. So you know from chemistry and when we did electricity that when you have charges, like a positive charge and a negative charge, that there's going to be a force pulling them towards each other. Yep. And just like with gravity, if this is charge 1 and this is charge 2, there's a formula to calculate this force, and it's given by K, Q1, Q2 over the distance squared. So this is Coulomb's law. Now, if you have your calculators, if you can take your calculators out, I can get you the K. Yeah. Distance, so I'll call it or. Since I think that's what we set for the other one. Yeah. And that's important. Now, a lot of the time, not all of the time, but a lot of the time we don't write K in front, we put a different constant in front. Sorry, I'll try and keep it here. Now it's still just a constant, but instead of writing as a big K, we write as a 4 pi over epsilon. And the reason for this is, number one, it's because of the unit system we use. And number two, the epsilon has some meaning, we can interpret it, whereas the K doesn't really. And also another advantage is your calculator has epsilon on it. So if you look at the lid, it's 32. So can you type it, let's see, you have it there, yeah? So if I just do 4 pi over that last number, oh hang on, 4 pi over shift, with the shift 7 and 52. Yeah, I just want the K. So just give that to me now. 1.42 is it times 10 to the 12. Okay. This K here is 1.42 times 10 to the 12. And the unit, you can work it out. Focus up here, Mo. The unit, you can work it out. It will be Newton meter squared per Coulomb squared. Both formulas are the same. Both can be used in the exam, and both constants are given in the exam.
So what is epsilon?
So what epsilon tells you is how good the space is at allowing the charges to interact. So it's a way of measuring the ability for charges to interact. Yeah. But that is something which is not on this course really, so we can just stick with the K one then. Okay. But some people may have seen it before. Now, as you pointed out, it is the same form as Newton's law, and that's important, because it means the formulas are similar too. So you know from Newton, you have F equals G, M1, M2, over distance squared, and for Coulomb, you have F equals K, Q1, Q2, over distance squared. But there's a couple of differences between the force between masses and the force between charges. So let's draw some pictures here. So if you remember, here is maybe a big M1, and then here is a small M2, and you know here is the gravitational field. And it's the same situation here for Q1, and then if there was a Q2 here, it's the same situation. But there are a couple of differences between gravity and then this electrostatic force, we call it. So it's the same formulas, same picture, same situation, but there are some differences. So I wonder if you can spot some differences between maybe the formula or between how the forces act.
The charges, they have to be opposite.
Yeah, that's one big difference. With the gravity one, they always attract. But with this electric one, they can attract or they can push away. Okay, so the difference is, first one, gravity only attracts, but the Coulomb one can attract and repel. So that's one big difference for sure. Any other differences that you might know of? Yeah, and that's important too. I'll give that as reason number 3. Something based off of the constant, yeah. Anything else? No? So, one other big difference, if you have one mass here and one mass here, and they are attracted to each other by gravity, is there any way I can stop this force by putting something in between? Is there any way I can block the force? What do you think? No, you can't. Okay, so you cannot block a gravity force. Okay, it goes through everything. But what about with this one? What about this one? Something simpler though. If you have two, you have positive and negative, they're attracted to each other. Is there any way I can block this force? Without using another charge. Yeah. You put a piece of plastic between the two, you can block it. So this is a big difference between the two fields. The gravity field, you can't block a gravity field. But with this electrostatic field, you can block it by putting up some plastic. Okay, so that's an important second difference. Gravity fields can't be blocked, but I'm just writing Coulomb for the moment. Coulomb force fields can't. Now Joshua, what was your reason that you had?
Different quantities.
So how do you think that makes things different though?
They can be equal.
They're definitely not equal. If you look here, which force is greater? Okay, so suppose here we have a unit mass, and a unit distance. Then what's the force equal? G. And here, if I have a unit charge, and a unit distance, what's the force equal to? Okay. Now, which number is bigger? Well, here's the K. And then what's the G?
6.67.
Yeah. Times 10 to the minus 11. There's a big difference there, isn't there? What's the difference? 10 to the 12 divided by 10 to the minus 11. So this force is 10 to the 23 times bigger than this force. So this charge, this Coulomb force, is a very, very strong force. Okay? Much stronger than gravity. Now, I've been calling it Coulomb's force here, but really to give it its proper name, it's electrostatic. So actually I'll write it here beside the formula. Electrostatic. Electrostatic force, and then this one here is gravitational force. If you don't have your Casio calculator, you'll need this constant. Okay.
What is the unit for kilo?
There it is. Newton meter squared per Coulomb squared. Yep.
Okay.
For K, yeah.
So what's for F?
For which one?
Force.
Newton. It's not like it's been that long since we were doing physics. Okay. I think what I'll do is I'll let you try these for a few minutes because they're short, and then the longer questions 11, 12, 13 and 14, I'll do that on the board. Yes, okay, so if we can try these for a few minutes, and then I'd like to do the last 4 on the board. I'm going to do 11, 12, 13 and 14. So 11 first. You got 2 negative charges. Their distance is 5 times 10 to the minus 2 meters apart. Okay. Charge A is 1/3 that of charge B. So you have 1/3 X, well I'll write it, sorry, Q1. Q1 is 1/3 X, Q2 is X. And I give you the force as well. What's A and B, or in other words, what's X? So, using the formula, so I'll just put the numbers in directly. 2.2 times 10 to the minus 4 equals K. What was K? 1.42, was it?
Yeah,
10 to the 12 times 1/3 X squared, because it's multiplied together, all over 5 times 10 to the minus 2 squared. So you get X equals square root well, 25 times 10 to the minus 4 times 2.21 times 10 to the minus 4. That goes, that's, sorry, and this, that's for 1/3 X. I'm going to have to take care of this as well. Let me put that underneath here as a 3. So there's a 3 here. And then underneath there's a 1.42 times 10 to the 12. So what do you get for X? 1.08 minus 9 coulombs. And then the other one, that's just 1/3 of X, 0.38, is it? 3.6 times 10 to the minus 10. Okay, so that's 11 done. So 12 now. Go down to 12? Yep. Okay, so 12. I haven't told you yet what an alpha particle is. So you don't know what that is. But, what's wrong? Is that the problem, or? Yes, what? You know what an alpha particle is? Oh, you do you?
Yeah.
Yeah, so what's an alpha particle then? Yeah, I haven't told you this yet. I haven't told you what an alpha particle is because alpha particles come into the next section on atoms, okay? But I'll just write it here for you. An alpha particle, it's 2 protons. 2 protons. And that's it, yeah, so it's just 2 protons, which is helium. Okay? But there's no, it's 2 protons and 2 neutrons, but no electrons. So what's its charge? No, it's 2. Yes? So, alpha particle is just this. Helium 4-2. What's wrong, Emily? Huh? His head is wrong. And there's many things wrong with his head, but we just have to live with it, okay? Anyway, we'll talk more about alpha particles in the next section, okay? But all you need to know right now is it has the charge of 2 times 1.6 times 10 to the minus, what is it for electron and proton, minus 16, is it? Check it on your calculator. Which constant is it? 23. Minus 19.
Yeah, minus 19.
The mass 6.68 times 10 to the minus 27, and the distance is 1 times 10 to the minus 9. And what you have is 2 of these. So you have a Q and a Q here. And because they're the same charge, they want to push away from each other. So can you tell me what the force is? It'd be K, Q, Q, they're both the same over R squared.
What do you know? Force of the
Yeah, the force. Come on, type it in. Daniel, have you done this? Type it in. For the next part.
4.5
10 to the 11 newtons. Okay. Now for the next one, because they have a mass, there'll be a small gravity force pulling them together. So this force here is G M over R squared as well. So what's that, please? And it'll be much, much smaller. What is this? This one? The next one, yeah? What's wrong, Tal?
I don't know why, but I guess different.
For which one?
The first one.
Mo, where's your calculator?
Yeah, if the first part is it undergoes repulsion, why are we using that formula to find the force? Isn't force the same?
It's the same. If they're pushing or pulling, whatever, it's the same formula that gives you the force which is attracting or repelling them. It doesn't matter the direction for the formula.
Even the charge that you put, that you said 2 times 1.6, is it for both of them or just for one?
That's for one of them.
2.
Yeah, this here is for one of the Q's. And there's 2 of them here, so they actually get, this all gets squared then.
It's 1.45.
Oh, so this is wrong here?
Yeah, the first one. 1.45 times 10 to minus 7.
Yeah, I was wondering why it was so big. 1.45
Times 10 to minus 7.
10 to the minus 7. Okay, and then what about this one then?
2.97
Yep.
by 10 to minus 45.
A lot smaller, right? A lot smaller. And the last thing they want is the density, which would just be the mass over the volume, which would be 6.68 times 10 to the minus 27 all over 4 over 3 pi r cubed, and the radius is 2.1 times 10 to the minus 15. .1 times 10 to the minus 15. Okay, what do you get here? For the density of the alpha particle. 861,
300.
361, 361.6 kilograms per meter cubed. Okay. 13 now. Now this one's a bit different because it mixes in, like what we saw last time, circular motion too. So you've got your proton and you've got your electron and they're orbiting. What atom is this? What atom is this? What are you looking at there? Hydrogen. Hydrogen. The radius is 0.5 nanometers. Use Coulomb's law to calculate the force of attraction between the... Okay, so first question is the force here. So force would be K Q1 Q2 over distance squared. So that's 1.42 times 10 to the 12 times 1.6 times 10 to the minus 19 times 1.6 times 10 to the minus 19 all over 0.5 times 10 to the minus 9 squared. So tell me what that is. That's just the force between a proton and an electron. They both have the same charge, just opposite signs. Okay, and then the next part, yeah. Isn't that the charge of an electron and a proton, if I remember correctly?
It's actually the same answer as it was in the previous question.
I think it's just coincidental, isn't it? Because this is between one proton and one electron. What was the last one?
One person. Two protons.
Oh, the distance was twice.
The distance was the difference, yeah, but they cancel each other. And then the next part is they want the omega. Now what formulas do you have for omega? Well, if you think about it, you now know what the force is. So you could have F equals m omega squared or. So then omega will be square root F over m or. So then omega is square root 1.45 times 10 to the minus 7 times 0.5 times 10 to the minus 9. And then we need the mass of an electron, which is on your calculator. What's the mass of an electron? Has it minus 27 in it?
9.11.
9.11 times 20?
30.
Oh, 31. Okay, so what's the omega here, please? Times 10 to the 16. So this is going very fast around. Are you sure about the 16 here? I feel like it should be small. Oh no, but we're divided by a small number. Yeah, okay. Can I scroll down, or do you need a minute? Okay. Last one, and then we go on to the next part of this. 14. You got your hydrogen again. except this time the radius is this. So what's the force? So it's the same, it's the hydrogen atom again, proton and an electron. So it's K Q1 Q2 Okay, so if you just type this in, tell me what you get, please. What did you get?
1.291 and 10 to the minus
1.29,
5. 9.
okay, times 10 to the minus 5 newtons. Now part 2, they want the kinetic energy, which means they want the velocity. So what formula could we use to help us get the velocity? Remember, it's going in a circle. What do you think? Say again? Is what? Force, yeah. Force equals mv squared over r. So that means f4 over m square root, that's v. So v equals square root 1.29 times 10 to the minus 5 times 5.3 times 10 to the minus 11 all over 9.11 times 10 to the minus 31 equals.
This formula is good.
Which one?
F equals mv squared.
I don't know, sure, didn't you get an exam paper recently just like that? See, it's kind of in there, it's the acceleration form of it. You multiply both sides by m. What do we get here? You got this? No. Yeah?
27.4 times 10 to the power
240.
27.4 times 10 to the power
27.4 megameters per second. Okay, good.